Okay, so have you ever actually stopped to wonder what exactly is going on inside a doctor's head when they're trying to diagnose a patient? It's wild to think about, but diagnostic errors are literally one of the biggest blind spots in modern healthcare today. And if you really think about it, it makes sense. We are so obsessively focused on the final answer, the diagnosis itself, that we completely gloss over the journey. How does a clinician actually reach a medical conclusion? Like, what are the mechanical, step by step, cognitive processes that move them from just a random list of symptoms to a definitive, potentially life saving judgment? Well, welcome to today's Explainer, where we're going to be decoding this really fascinating framework called clinical cognition from first principles. You can honestly think of this as the ultimate operating system for medical decision making. We're looking at a system here that's designed for both clinicians and technical readers that fundamentally rewires how we understand medical thought. It takes it from this kind of mysterious, untouchable art form and turns it into a highly structured, auditable science.
Here is our quick roadmap for the explainer. First up, the invisible made visible. Then, building the core engine. Third is Lesson 9, the master protocol. Fourth, beyond a single diagnosis. And finally, we'll wrap with the evidence complement. Let's just dive right in.
Part 1. The invisible made visible, where we force the reasoning trace into the open. So here is the core issue we're tackling. In modern medicine, the focus is almost exclusively placed on the final destination. Did they get the diagnosis right? What conclusion did they reach? But focusing just on that entirely misses the cognitive mechanics it actually took to get there. To truly understand, and more importantly, to improve clinical cognition, we have to shift our entire focus to how reasoning actually moves. Why does the reasoning behind a diagnosis usually stay completely invisible? And what does it look like when we use tools like Socratic questioning to drag it out into the light so we can actually study it?
Moving right along to Part 2, building the core engine, which covers lessons 1 through 8 of the framework.
To fix this invisibility problem, we literally have to build a core cognitive engine from the ground up. And this machinery is assembled in very deliberate, methodical steps. It all kicks off with a Socratic loop. That means forcing a genuine attempt at reasoning before you ever reveal an answer, mostly because questioning a learner changes what they retain way more than just feeding them facts. Next up is differential building, which is transforming raw clues into a probability-weighted list of options. Then, of course, we audit for biases. And finally, we hit calibration. This is cool because instead of a simple, oh, I'm 80% sure score, we use multi-domain confidence reporting. That means we're actually grading confidence across completely different variables and contexts. What's really fascinating here is that this cognitive engine borrows failure analysis concepts straight from structural engineering. It's looking for exactly where the reasoning breaks down. For instance, it audits the precise moment of commitment when a doctor locks into a diagnosis. It searches for the load-bearing finding. Think of it like the bottom block in a Jenga tower, holding the whole theory up. If it's wobbly, the whole thing falls. It also checks for signal versus noise, the distortion that happens when a patient is handed off from one doctor to another, and the massive difference between analyzing a single medical record versus population-level registries. Every single component here is engineered for safety. Okay, we've made it to Part 3, and this is truly the absolute climax of our explainer. Lesson 9, the master protocol. It is time to turn the engine on. Now we reach the absolute core of this entire framework. You can think of Lesson 9 as the ultimate stress test. We are taking every single thing we just built in Lessons 1 through 8, the Socratic questioning, the probability weighting, all those rigorous safety checks, and we apply it all to one single patient case from start to finish. It is an unbroken chain. We aren't just looking at isolated pieces of the puzzle anymore. We are running the core cognitive loop end to end to capture the complete, comprehensive reasoning trace of the clinician. The whole goal here? Transforming what is usually a super messy, totally invisible thought process into one concrete artifact. I mean, imagine if you could literally print out a flowchart showing exactly how your doctor's mind moved from your very first symptom all the way to their final diagnosis. By running the full case start to finish, the master protocol captures every pivot, every weighed probability, and every audited bias. It generates a tangible record that can actually be read back and reviewed. And having that physical artifact allows us to finally ask the most critical question in all of clinical cognition. Does the trace hold together? By looking at this complete start-to-finish record generated right there in Lesson 9, we can evaluate the actual structural integrity of the logic. If a single load-bearing finding is flawed, boom, it's exposed right there on the page. If a bias warped the differential, there's absolutely no hiding it. This is exactly why the master protocol is the focal point of the whole system. It proves whether the core engine actually works in reality when it's totally exposed to the light. All right, part 4, beyond a single diagnosis. Now we're going to scale this machinery up. So once the master protocol is proven to work on a single full case, we can take that cognitive engine out on the open road. First, we scale it up to healthcare systems and operations. This means handling workflows where a patient is handed off between shifts using what they call distributed differentials. Next up is precision medicine, which is actively weighing conflicting evidence alongside the patient's own preferences. And finally, and I think this is perhaps the most fascinating one, clinical wisdom. This is all about capturing the tacit knowledge of master clinicians. You're essentially downloading their compressed intuition so you can spot the difference between true expertise and just a dangerous shortcut. And for those who really want to push the engine even further, there's a whole toolkit of optional electives covering advanced applications that are kept out of the main sequence. We're talking about things like N-of-1 research, structured journal reading, community medicine, thematic analysis, and longitudinal cross-case learning. It is essentially an absolute master toolkit for anyone wanting to apply this cognitive operating system to the very frontiers of medical science. Which brings us to our final section today, Part 5, the evidence complement, the sibling course. To really wrap our heads around this framework today, we have to look at the other half of the equation. There is a vital sibling framework focused entirely on evidence-based medicine, or EBM. Now, EBM asks questions like, can I trust this data? Is the study flawed? Is the sample size right? But clinical cognition asks, how did I get from those findings to a judgment in the first place? Think of it this way. One framework audits the raw materials, while the other audits the factory that processes them. You really need both. Because these two tracks are so complementary, meaning you can actually start your journey with either one, I want to leave you with this final thought. You've just seen how the master protocol can literally map the human mind from start to finish on a case, and you've seen how raw evidence can be audited. So, when you decide it's time to make your own reasoning visible, which track will you choose first? Will you start by questioning the data, or will you start by questioning yourself?